So I would like to introduce our new speaker today to integrate. So this is his first integrate. So let's welcome Alex Karcher.
Hello.
Hello. Sorry. So Alex currently working as project manager at Microsoft for last 3 years, but he brings with him a huge experience in automation. In one of his previous engagements, he has automated the setup of developer framework. So with this very few words from Alex, good luck. Let's start the Integrate Day 2 with your session.
All right.
Thank you.
So I've been told that I have to wake everybody up. So this presentation is going to go on for about 20 minutes, and then very loud sirens will keep everybody very engaged. So I'm taking over for Jeff Holland. If you kind of close your eyes and squint, I look a little bit like Jeff Holland. He's my manager at Microsoft. So this should be fun. This is 5 tips for production-ready Azure Functions. And because you have to submit these titles so far in advance, you can kind of think of it as 5 tips for production-ready Azure Functions. So let's get moving. So the first tip that we have for production-ready Azure Functions is a bunch of common architecture patterns. These are patterns that all of our customers keep coming back to us and implementing, and we figured we should have some guidance on what they're doing so that you can have the most successful functions experience. I'm going to get into a lot of detail on the first 2, but there's also an integration service bus pattern where you kind of put all of your apps behind some sort of message queue and use that to integrate line of business systems. And then the entire kind of digital transformation, lift and shift and make better pattern that you can read customer testimonials about after this. So the first tip is how to most successfully build serverless APIs with HTTP in functions. And this is the same pattern that the Have I Been Pwned site uses, that Quest uses, that Starbucks uses. You can look up public use cases for all of those. We have so many customers that come back to us with this exact scenario. And it is, they've set up their app something like this. There's a public traffic manager that your customers are going to reach, that a mobile app, a website, somebody integrating with your service directly is going to reach. And that traffic manager marshals traffic between 2 different copies of your entire infrastructure. So a bunch of functions sitting behind API management in a failover configuration, and then some sort of geo-redundant database behind the scenes. And this allows your application to survive an entire region going offline for a large or a small reason, for a short amount of time or a long amount of time. And we specifically see a lot of people use API management behind Traffic Manager because they can route traffic to the correct region while still having that failover, that active-active configuration to load balance if one region gets a lot of traffic. Also, Functions doesn't directly integrate with Traffic Manager, so you need something in between it to give Traffic Manager all the information that your app is actually up behind the scenes. So we also see a lot of people hit pitfalls when they try to scale with HTTP massively. So I want to take a little bit of time to explain how the HTTP handling logic works in Functions, because it's a bit different than every other trigger that we process. This is how the support team would have you believe our HTTP handling works. HTTP requests come into a black box and then leave that black box again. But behind the scenes, it's a little bit more interesting. We have kind of the gray haze of Azure infrastructure, and in front of it, we've exposed 2 public endpoints. The first is our shared front end with all of your services, and the second is a scale controller shared between all of the different services that manages your app scale out. So an HTTP request comes into your application and is handled by the front end, and the front end on that very first request calls back into our shared infrastructure and stands up an instance of the function's runtime. And there's a really, really good article that Colby Tresness wrote on Cold Start that explains everything that happens when your site boots up. But there is a functions instance that needs to be stood up on a virtual machine, and then the functions runtime that needs to be instantiated within that instance, and then your code that needs to load up inside of that instance. So all of that happens, and then every further request that comes in, and then your app returns a response, hopefully. And then every other response that comes in goes into that existing site. So at some point that site becomes fully loaded, and the scale controller, seeing the queue length of your site, makes a call out to span more instances, and then that information is propagated up to the front end that load balances between these instances. And given the nature of HTTP, given the one connection nature of HTTP, there exists a world where if that one instance is running a very, very long-running operation, it could be stuck chewing on a bunch of requests that have already come in while there are 2 unused instances sitting on the side processing very few requests. So as you're building HTTP applications, this is something to keep in mind if you have a really, really long-running service. In words, all of the scalability considerations, I think I covered most of this already in pictures. In HTTP, the scale controller sees your queue length per instance, so it knows whether it needs to spawn more instances that way. But in all of the other queuing services, it just looks at the overall queue depth. So if you have 100,000 messages waiting in a queue, it's going to spawn off instances regardless, even if you have a very, very single-threaded workload that's only processing work on one instance. You also have a bunch of controls over your app. The most important is the host.json that allows you to configure how many instances of the runtime are running on the same site. Actually, going back here, these function instances, you can think of them as running one function's runtime, but we can actually spawn this process multiple times. So if you have a lot of async await operations, we'll run, I think the default is 4 instances of the runtime at the same time, so they can all be not jockeying for resources. So this is in the consumption plan and in the app service plan, but we have another plan that offers a lot more scaling controls, and it's called the premium plan. And to get into it, I'm going to talk about the scale in a little bit more abstract terms. This is the function app serverless scale graph as drawn in every serverless meetup ever since the beginning of time. In the perfect world, when your app is running with no load, it's scaled down to 0 instances, and then in blue, once load starts to hit your site, it will scale up to 1 instance, and that instance is available immediately. And then once that instance is fully loaded, it will spawn off a new instance and so on and so forth. And then when your load falls off, we're going to keep those instances around, not charging you, while we make sure that your load is falling off correctly. So if you have another spike, you don't have to wait for more cold starts. In reality, though, a lot of people come to us with apps with really long cold start, and their scale curve looks something like this. When that first request comes in, it's some length of time before that first instance is available, and then even after that instance is online, you're lagging behind your scale curve as you're scaling out. And for the longest time, we've been telling everybody, hey, break your app into smaller components, remove dependencies, try to simplify your application so that it starts up faster and your scale curve looks more like this and less like this. But with the premium plan, we have another option, which is to pay for some number of instances to be running at all times. So in this example, we have 6 instances running at all times, and we have your runtime loaded on one of them. And as your requests come in, the moment we need another instance, we'll warm up another one and keep one more available ahead of your load curve. And you actually get these specific controls, these 3 controls for your site. You get a number of pre-warmed instances per application, and then for your plan, you get a minimum and maximum instance size. These are 2 controls that people have been asking for a very long time. The minimum instances is what I'm the most excited about, but a lot of our customers are most excited about the maximum number of instances. We've had a lot of people drowning downstream services with massive scale out, and being able to curtail your app to only use 10 instances is a really powerful control. So in this example, to be very, very clear, we have our 6 instance minimum plan size, and you could run that down to 3 instances where for the first 3 bumps of your scale curve, you are scaling ahead of the curve. And then once you're up to 3 instances, you may decide, hey, this small drop in latency is going to be fine because you're still going to be processing load on those 3 instances. Instead of seeing 7, 8 seconds for that first request to get answered, you'll see something like 100 milliseconds, 50 milliseconds. You will see some increased latency because your app is over capacity, but you're not waiting for an entire new instance to come online to process load. This behavior also allows you to bunch apps in the premium plan a lot more densely than you can in the app service plan and our dedicated plan. In the app service plan, your app is running on every single instance that you have provisioned. And in the premium plan, we're using the scale controller to control how many instances you have. So you could have 30 apps on this plan all set to 0 pre-warmed instances, and then 2 really important applications set to 1 pre-warmed instance. And as requests are coming in and out, when you scale out that one particular site, it will scale out within those instances. So that's a bunch of tips for HTTP processing. Moving on to tip number 2, event stream processing. This is another scenario that we see a lot of customers come to us with basically the same topology, so I figured it is well worth having some best practices around it. Specifically, there are public use cases for Starbucks, Honeywell, and Walmart all doing the same pattern. And it looks something like this. They have devices and clients writing messages into some sort of message queue, usually Event Hub or IoT Hub, but there's a few more that I'm pretty sure Dan talked about yesterday. That message bus goes into functions, which then talks to Cosmos DB. They go to some sort of database, usually Cosmos DB if they're in the Microsoft world. And there's a couple of particulars around scaling in this scenario that's really important, especially in the IoT Hub, Event Hub space. Rather than having abstract boxes, I will draw more specific objects. You have a pool of devices and clients, and then your IoT Event Hub that is broken up into partitions. And the default is 4 partitions. Your devices, when they connect to your messaging service, will get a partition key, and every single message that that device sends to the partition will go to that same partition. And so your function as well gets a lease on that partition. And as messages are streaming through this service, they're processed in order, both from the device into the messaging service and from the messaging service into the function. And in the device land, this is all hunky-dory. Oh, and I even have a message going across. In the device land, this is all hunky-dory. They can scale out to multiple partitions, and each device will get a new lease on the partition, and then when you add a new partition, or when you add a new device, it's going to double back on those partitions, and there's going to be a many-to-one mapping of devices to partitions. And in each partition, the messages are going to get processed in order, which is very, very powerful, especially for real-time applications where the order matters. Where people start to get gunked up in this scenario is when they're trying to scale out the function app behind their instance. So where people run into problems with this scenario is when they start scaling out their function app, because although the devices are many-to-one, the function app is one-to-one. So this function app in the one app scale out has a lease on all 4 partitions, but when we scale out our app again, when you scale out your instance, the next instance is going to grab half of those leases. And when you scale out again, your app, each instance of the function app is going to have 1 lease on 1 partition. And because we need to guarantee that in-order processing, we can only scale out to 1 function app per partition of Event Hub. And so this app is now limited at 4 instances of max scale out. So no matter how much traffic is going through, and no matter how much the scale controller wants there to be more instances, there's nothing for them to read messages off of. And so you have a couple of controls over scale out to make this better. The first is processing messages in a batch. I believe this is configured by default for functions, but you can configure it to read up to 100 messages per pull. So rather than needing to establish a new connection with Event Hub, pull 1 message, tear down that connection, and then wait for the next message, you establish a connection, read 100 messages, and then process them all, and then make a new connection. This gives you much, much, much more throughput in Event Hubs. About 2 years ago, there was a blog post that Paul Badum wrote, one of the engineers on our team, processing 100,000 messages a second in Event Hub, and for that, he was pulling 100 message batches. You only have 1 active instance per partition, but you can increase your partition size up to 32 in Event Hubs. And also in functions world, now that we have the premium plan, you can increase the size of your instances. So even though you'll have 32 instances, there will be much larger, much more able to process more messages. We've covered guarantee ordering. In the Event Hub world, you must handle the exceptions yourself. There's no automatic dead letter queuing, but we do have a bunch of other messaging services, and some of them do offer dead letter queuing and much more advanced message processing. So tip number 3 for Event Hub scale options, you can raise your partitions up to 32, but if you would like more partitions, you can open a support ticket and they will gladly give you more partitions. In that example that Paul processed 100,000 messages per second, we opened a support ticket, asked for 100 partitions, and they gladly gave them to us. And also you can increase the instance size. I've covered that already. Awesome. So moving right along, we have kind of our next tip, and this is how most of our customers are building their applications and actually deploying them into production. In the serverless world, it's very important to have both a really good inner loop and really good outer loop of development tools, because you're usually not just developing one easy to debug monolithic application, you're developing 30 applications that all integrate together and pretend to be one application. So there needs to be some sort of way locally to debug your applications and remotely to deploy them. We've had a lot of really good inner loop tools for a long time, but what we've been lacking is good outer loop tools, or at least we've been lacking a good way to set up good outer loop tools. So kind of tip number 4 is our Azure DevOps CI/CD integration, which has been improved immensely in the last couple of months. At Build, we actually just announced a bunch of new functionality in DevOps. We introduced a functions build task, which allows your function app to automatically be built by Azure DevOps. This is how it looks when you're deploying a DevOps function app. You now have the option to click in and add a build step for .NET, Node.js, and Python. You used to have to import PowerShell commands and do this manually, and you can now do it automatically. We also have added a streamlined CLI command. You do AZ function app DevOps pipeline create, and it'll ask you a bunch of questions and create a DevOps pipeline for you. It takes about 5 minutes, so you got to go get a cup of coffee, but you at least now do not have to go and configure everything automatically. And there's a really good short link for that new DevOps integration. We see a lot of customers in the DevOps space deploying 10, 15, 20 function apps all together. And Function Apps has a functionality called slots that is supposed to make this integration a little bit easier. But in reality, a lot of people run into problems with slots. And so my kind of tip 4.5 is if you are doing staged rollouts of your function app, all of the customers with production solutions that come to me have multiple copies of their infrastructure. One that runs the other version, one that runs version 1, one that runs version 2, and then when they want to rev version 3, they replace version 1 with version 3 and then do that swap. Slots still in public preview, been in public preview for about 2 years. So it's coming along quite nicely. But a lot of people find that it's easier to just have multiple entire copies of their application and use something like Azure DevOps to connect them both together. Once you've deployed your application and then are running it in production in the serverless space, it's often very, very tricky to figure out what your application is actually doing, especially because you have 30 applications all pretending to be one. And so my tip number 5 for monitoring is to use our Application Insights integration. It gives you a bunch of different functionality. The first is real-time observability of your site running. You can go into the live metrics stream in the Azure portal and see your application running in real time. You can see the instances that it's scaled out to, the CPU memory usage of each of those instances. This gives you the ability to troubleshoot as you're scaling to see, am I actually getting the amount of instances I expect? Is there one instance that's pegged at 100% CPU but using very little memory? That is an indication that you should have some wider scale out. Is there an instance pegged at 100% memory but using very little CPU, which is almost always something wrong with your code? You can kind of peel back the curtains and see what's going on with your infrastructure behind the scenes. We also have a really good distributed tracing and application map support in App Insights. The application, oh my gosh, this is a GIF, wow. The application map allows you to correlate requests as they go through your site. I wish I could pause this, but we're just going to have to see as it goes through the application map. This right now traces requests through HTTP and Service Bus and gives you that nice map view that correlates all of your different requests together. Gives you a good flowchart view of your site, the same kind of view that you would draw if you were drawing it on a whiteboard. It gets generated automatically. I really like this example because I'm using Service Bus to connect these apps, but I haven't actually done any what's the word I'm looking for, definition to show the connection between these sites. It's just using the real-time traffic information to generate this graph for me. And I want to drill down a little bit more in a non-moving image into this distributed tracing view. This is particularly what's kind of generated behind the scenes, behind the application map. And this to me is the most powerful debugging tool. It allows you to see a bunch of different invocations as if they are one large message stream. You can see a timeline of your apps, and then under that View All Telemetry button, you get the stream of all of the logs from all of your services as if it is one big application. This is really, really powerful for troubleshooting because often the error will happen at some point in your application, and without having to open up 13 different sites and all of the different log streams and correlate them together, you can use Application Insights to see that instead. So that's actually all of the content I've prepared today. So I can either go back and answer questions, or I can try to connect to Wi-Fi and do a demo. I believe we will have a fire drill in 4 minutes, but I can do about 10 minutes of Q&A if you all would like.
Could you show us a DevOps demo or something?
I could. I will actually need... Yeah, certainly. I can show you. I've created a DevOps pipeline for another demo, so I will actually pull that up over here. So this is the DevOps demo that I did at Build. I set it up with that CLI command. It's the DevOps project DevOps done in my organization Karcher DevOps done. And if I go in here, I can see my project. And I'm going to go specifically to my pipelines, and I'm going to look at my build pipeline. So I can see a couple of different builds that I've done. And I can actually go in and edit this build task, and I can see the YAML that the build tool generated. I didn't have to look at any of that. Oh, I don't want to get away from that quite so fast. I didn't have to build any of this, but it was all built for me by the CLI, and I can build off of this DevOps pipeline in the future when I want to expand my project. You can see here, if I go into one of these build tasks, it has really nice integration with all of the different build tools. All of these things you used to have to set up in PowerShell, and they now get set up automatically. As the build is going off, all of these update, and you actually get to see the specific bash output for the build task. And if you go into releases, you can see here, eventually, in my releases, you can see all of the releases that I have made. Once the builds finish, they get promoted to a release. And you can tell that this release is something that I built with the CLI command. It is called build_alkarcher-devops done-deva_devops-done_devops-done. And when you're using the CLI command, this is tip number 6, it will ask you to name a lot of things, and you should not name them all DevOps done. I can also show a premium demo now that I'm on the Wi-Fi. Unless anybody else has any questions. So I have both a consumption app set up and a premium app set up. I have what I believe is 15 minutes, so I can show both the consumption and the premium app. This is a consumption app running. It is not in any way scaled out. The live metric stream in App Insights actually shows us that the app is totally offline. So if I go into my load tester over here, and I'm using an external load tester because I don't want to have anything up my sleeves, and I run this consumption load test throwing 800 requests per second at this application, I'm going to see over here it come online and watch the scale out behavior. So we can see it blink online. The servers count up at the top is what we want to be looking at. And I can see it scale out over here in the request rate. I can see my overall health of the system. So it's showing me my request duration in a sampled view, and then it's showing me all of my instances. And so in here I can actually kind of take the servers back into my serverless app and see what is happening behind the scenes. I can see all of my instances running down here, and I can see my load curve very nicely growing to a little over what my inbound request volume is, so that it can drain that HTTP queue that's built up and then scale back down. And if I go over here to my load test, my very, very small load test, there we go. I can see my maximum request time, my minimum request time, and my, in blue here, 1 second rolling average load. And so you can see at the peak of my app running at about 10 seconds, it hit 6 seconds of average load. And then it took it about 35 seconds to stabilize down to about 100 milliseconds of average request time. So I had about 30 seconds from a dead stop before my app was ready to handle a production workload. And I honestly think that that's really good for something that is totally free to sit idle. I think this is an incredible load curve, but obviously not what you want to be surfacing for a production application. So if I go over here to my premium app, I can actually see it's also offline. Somebody was running this demo while I was not in it. So I'm going to go to Karcher Premium next and see what's up. This is good fun. So here, if I go into my function app, we can actually see all of these sliders, which is good fun. And I go into the scale out settings, and hopefully I will see, oh no, I should see that it should be running. Weird. Well, we'll throw a load test at it and see what happens anyway. We may watch a cold start, we may not. I should take this moment to let you all know that the premium plan is in public preview, not generally available. So here, we'll do a fun live demo. We'll see what happens. So I will throw a load test at it, and perfect. It was up, it just wasn't connected to application insights. So I can see my application starting up. It actually should scale out to 2 or 3 instances. So we'll see a little bit of a knee here, but it is much lower than it would be in the consumption plan. We hit a 1-second average of 62 milliseconds and then immediately stabilized. And yeah, my live metric stream popped up. So yeah, that server was there. It just eventually timed out from its App Insights connection. So tip number 7, right? Sometimes if your app is idle for weeks at a time without being demoed, it will time out its connection to the live metric stream, but it's still back there. It's still up under the covers. So yeah, we could see our scale out to 2 instances, and we see a little bit of latency from that 2 instance scale out, or at least I see it. Now we all see it. And you can see over here our CPU processes as well. These are 4-core, big honkin' VMs, because I want this demo to go well every time. And so you can see your process CPU is actually the percent sum across all cores. And so I'm sitting tight at about 200% CPU usage. So that is how the premium plan behaves in real life. I think it's pretty exciting, good enough that you could demo it without prepping your demo the night before. Cool. So yeah, I have time for Q&A. Meow can come up and set up his computer.
So how does this differ, scaling out? You can use the app service.
Yeah.
App service also has a scale functionality on the scale. How does this differ to app service?
Perfect question. So the question for everybody else was, how does the scaling behavior of the premium plan differ from the app service plan in its scale out? Because the app service plan does have the ability to scale, and it has the ability to set up auto scale rules. And specifically in the premium plan, you have access to the scale controller to inform your scale decisions. And so you set your plan size the same way you would in an app service plan, and then the scale controller makes scale decisions above that on a per second basis. So in the app service plan, you scale up on 5-minute rolling windows for your metrics. So if you set an HTTP queue length scale trigger or CPU scale trigger, it'll make a decision based on the last 5 minutes of data, whereas the scale controller will be making more or less real-time scaling decisions. Also in the app service plan, as I had said before, your apps run on, every single app runs on every single instance that you've provisioned in your app service plan, whereas on the premium plan, you're only running on that number of pre-warmed instances you've specified. So you can pack your apps a lot more densely inside of the premium plan. And while I'm at it, the networking functionality for both of those plans is very similar. There's actually a really good doc about this that I wrote, which is why I think it's really good. It has a matrix of all of the networking functionality for the app service plan, the premium plan, and the app service environment, our big isolated SKU. And the premium plan has almost all of the networking functionality of the app service plan. The big missing piece is the hybrid connection component. You can restrict all your inbound traffic. You can connect to a virtual network. You can restrict your inbound traffic to a virtual network. But the thing that you can't do is that hybrid connections, which is our software VPN. It lets you run a hybrid connection manager on a single machine on premises, and then use a layer 8 VPN to connect up to Azure, kind of poke a hole through your firewall. So that's available in the app service plan, but not in the premium plan.
Is there a plan to get that support, like the access?
Yeah, the question was, is there a plan to get that supported? And right now there is a plan. It is about 50-50 if it's going to happen by GA, but there is a plan to get it working. At the moment, the limitation is on the scale out of the premium plan. The app service, the hybrid connection only supports 20 instances. And so if it works, it will work up to 20. And the question is that good enough for GA? A question that I will answer in about 4 months. Thank you all very much.
Cove.co